So we already learned about the 2-dimension, okay? Yeah,
Yes.
xy, right? That is only about the 3-dimension part. Yeah,
Yes.
clear? Yeah. So in this also we have to represent with the vector, right? Okay, vector could be anything, right? Okay, how much displacement is happening, right? Okay, and what is the velocity here over this point? Okay,
Yes.
what is the force on this point? Clear? In this direction, clear?
Yes.
Understood? Changes over the period of time. Okay, that's everything we have to calculate like this. Okay. Now, okay, this part generally we have to this part of it. Okay. So what is the positive component over here? This one, right? A. Suppose A is there. Okay, A is like a something like a number. Okay, over there. Yeah, I'm saying the
Yes.
5. So and this is a theta. So this should be the 5 cos theta. This is the 5 sin theta. Clear? Which is
Yes.
also represented like this way. Understood? We did earlier. Oh. Same way over here now. Here what we have to do? Here also we have one line. Clear? Right? Dimension. But you have to put a one line like this. You can see? Yeah, this is a plane. Understood? One plane,
Yes.
right? 3-dimensional part. So this is like this way. So what we have to do over here, okay, we have to see x, y, z, okay? You can take anywhere x, y, z, there's no problem with that. So you have to see that, okay, what is the angle made by the x and this angle? Fine? A. So, yeah,
Yes.
between this to this. Clear? This is suppose I'm taking the theta x. Clear? This one,
Yes.
y and this angle. Okay? Theta y. Clear? Right? Z in this, theta z. Clear? In 3 dimension we have to see, okay? Not like we have to turn us for this one. Clear this one? Right?
Yes.
Okay. This theta x, theta y, theta z, okay? That will explain what to you? By how you can able to do. You have this one, right away? This part. Clear? A vector. Yeah?
Yes.
Understood? I'm just putting over here, but I'm just taking this theta x, yeah, and in the x direction. Yeah, I can take this part to here also as it. Yeah,
Yes.
vector. No, I can just put okay for the easy calculation part, right? So how much this will look apart? They're the same. They're the same, right? Okay. Only I'm just doing it like this. Okay, like a circle. Yeah,
Yes.
clear. So how much it should be? This point, theta x, this one, okay, and this one. Okay, what I should know? This part. Yeah, right. X-axis. Yes, sir. Yeah.
Yes.
Another way is what? You have to put a perpendicular line. Yeah. Clear?
Yes.
You have to get a perpendicular line. Okay, then what we have to do? Yeah. And this, how can you find out? This one, theta x, then. How can you find it another way? Think. One I can do like this, no? Yeah. Yeah. Okay. It's like this.
Frozen, sir.
Trojan. Thanks.
Yeah, you're frozen, sir.
Trojan. Okay, my page is Trojan. My page also
Sir?
Trojan. Huh? The page also Trojan. Pawan. Page is also Trojan. Pawan. Page also Trojan. Pawan. It's okay. Clear to you?
Yes.
Okay. So what is this particular angle? This angle is major theta. Okay. Yeah. This particular angle part. And there's a 90 degree over here. Okay. Right. You have to find this particular part. Okay. Due to this one. Yeah.
Yes.
So you can able to find out of this one also. Like this way somewhere. You have
Yes.
this one. Right. Okay. With this particular part angle you have. Okay. You can find this one. Okay. What is the distance? If you know that this distance, it means that you know this distance also. Hmm?
Yes.
Something. No, not yet, sir. Something you can able to find out not over here. Okay. No problem. You, your health is not good.
I think you can find out.
I'll send it to you. Okay, fine. Now
Yes.
the third thing is what we have the direction. This is called the direction cosine. Okay, fine. So this x side. Okay, x side. Okay, y side. Okay, z side. Because all the three angles I need to see that. Okay, how much is deviating from the these axes. Okay, right. So this is the theta axis will be the this. Yeah,
Yes.
this part. Okay. Yeah. What is this part?
That's the x9.
Theta x. Yeah.
You can use like
Mm-hmm.
Pythagoras to find like the side, and
You
then
have to
like
use the okay, no problem. Okay, you have to use the L square plus M square plus L square. Okay, generally. Yeah, element. Fine.
yes.
Distance. Okay, so cos theta x. Okay, cos theta y. Okay, cos theta z. Fine. You can able to find out in between the differences. Clear? If you do the square of all, right away, you'll get a one. Okay, with the spot. It means that how much contributing factor are there. Okay, what's the direction ratio? How much moved? Okay, how much moved? Clear? If
Yes.
something is moved up till here, something is moved here, right? Okay, something moved here. Where is the net part? Clear? All moved. Which have to satisfy all the things. So what you have to do? X2 minus x1, y2 minus y1, okay, z2 minus z1, okay, in these all points. Clear? That should be satisfied. Okay, that's why we are seeing the traction ratio. Okay, that is the LMN. Yeah.
Yes.
Okay. Clear?
Clear.
LMN or you can take anything. Also, there's no problem with that part. Clear? So one is for the how much angle, okay, from each side. Clear? Okay, plus how much distance. Clear? Is the same thing with what angle you are going, okay, and how much your distance covered. Okay, understood? Distance
Yes.
covered with respect to, if I say that what is the x side, I make a, suppose I'm saying the 5 point. Clear? So I will mention the 5i. Okay, this is my unit vector for the x. Clear?
Yes.
Okay, x side. Understood? So I can see that, okay, according to x axis, it's 5. According to y axis, something else. According to z, something else. Okay. So in the space, I will to find it. Clear?
Yes.
Understood that part? All? Hmm?
Yes. So
Okay. Now you have also the orientation part of your graph. This is right. Okay. There's a plane. Clear? What the equation of the plane generally we have to use? Ax plus by. Okay. Plus cz plus t. Okay. It's equal to 0. Clear? Fine. Point should be x, y, z. Equation of a line should be x, ax plus by. Okay. Plus cz. C is equal to 0. Cz. Z should be there or not?
just should be there. So
Okay. So what is the equation of the line in 3 dimension?
it's the
Minus d or
R.
plus d? Huh?
Isn't it like the RX plus
No, no,
Y?
not Rx, not Rx. If I just say that, okay, you have to put Ax plus By, okay, is equal to 0, A is equal to C. Clear? Now, same way for this one also, you can put something. Think for that, okay? Now,
Yes.
what is this one? D part. D is that this, how much from the 0. Clear? Understood?
Yes.
Okay, if you bring over here, then there's a 0 you have to remove. Clear? A, B, C, I told you. Orientation of X, right? Okay, towards the X, how much? Clear? Toward the Y, how much? Toward the Z, how much? Okay? Turn part. Clear? 1,
Yes.
0, 0, 0, 1, 0. Okay, 0, 0, 1. Okay? What will happen? A, B, C. 1, 0 means totally toward the x-axis. Y-axis, z-axis will be 0. Okay. So it means that toward the x-axis side total. Yeah.
Yes.
Clear? Like this way. Right. Now we have also the another part. That is normal vector. Okay. What is the normal vector over here? Generally, we have to see the plane, right? Okay. Plane in which direction and line in which direction. Okay. Clear? Understood? The point is anywhere. Could be. Yeah. So generally, we have to
Yes.
make a equation for the two things. Okay. We have to make a 3D line. Okay. And 3D plane. Clear? Right? Understood? So
Yes.
generally we have to see the intersection of the 2 points. Okay, there's a parallel, perpendicular, or something like axis. Right away, theta. Clear? Fine. Second part, we are using the plane here. What satisfy the ax, okay, plus by plus cz, okay, plus d is equal to 0. Got it?
Yes.
Then what? Normal vector, okay, clear? We also use the two planes, okay, to see that, okay, there's a parallel or not, okay, or perpendicular or not, clear? Okay, right?
Yes.
Or what should be the angle between the two planes, clear? One is called the skew line. A skew line means in 3 dimension, okay, I'm saying that there's a 1 point, okay? Suppose I'm saying the plane is over here, okay, aeroplane, okay, at the height of 13,000 feet, clear? 3,000 feet, or you can say like a 13,000 meters, right? Sorry, understood? And second will
Yes.
be also in the same parallel path, okay, but in different direction, okay, right? In different direction, okay. So that will be over here in the 5,000, you can say 10,000 meter, yeah, right?
Yes.
So thing which is in at 13,000, okay, and 5,000, right? They're not going to meet each other, right? They can cross, but over the plane, right? Space, 3D space path, clear? Due to jet, okay, or any part, okay, they will not going to be connected. Yeah, so that is called the distance between the two lines, right? And here, when you see the perpendicular line between, okay, perpendicular distance between them, that is the shorter distance. Clear?
Yes.
Which is also you can say that okay, this line is supposed to make a plane, right? Okay, I'm saying the orientation of the line and make a plane. Clear? And here also make a plane equation. Okay, and I can see that okay, they are not going to connect to each other or they are parallel to each other. Okay, the same condition I have to fulfill over here. Understood? Means from the two
Yes.
points, okay, or from the equation of the line, okay, I'm just trying to make a something like a direction and perpendicular. Okay, you can say the parallel on this plane, right? Okay, plane part. Yeah.
Yes.
Okay, and distance between this and this, and I can just check the what is the parallel distance between them. Clear? Right? That is also you can say that part of the skew line. Clear?
Yes.
So generally these are the combinations, right? Only. Fine. Now you have to see the some part of the vector is that something here. Yeah. Yeah.
Yes.
This is the point normal vector. Okay. Clear? And this is the point you can see that. Okay. Something they will tell you. Yeah. Like this. Right. So this is what here. What you have to find. You can able to find what? Okay, towards the normal part. Normal point to here point. Okay, I want to see the distance between the two. Clear? Over this point. How can I will find? I have to see the plane. In which plane surface particular they are. Yeah. I need to find
Yes.
R0, right? So I know that it's also like the cos omega theta x. Okay. Theta y, theta z. Clear? For this also I will know that theta x, theta y, theta z. Okay. Right? Clear?
Yes.
What is the IJK? What is the IJK works over here? Okay. Yeah.
Yes.
Which point should be satisfied for this particular equation, right? Okay, of the plane. Okay, that distance will be there we can get. Understood?
Yes.
Okay. So I can compare everything with the orientation also part. You can also write as a in the matrix form. Clear? X, Y, Z. Easy to do the operation. Clear?
Yes.
Wait.